Now see next question number second from exercise 1.1. Differentiate the following with respect to x. First sub question, cos of x square plus a square. So first we see here which function given here. Here function is cos of x. So this is of the standard form and this given value in the composite form. So first we know the formula for standard derivative. So with the help of that you can find the derivative of this composite function. So first we have to check here outer function. So we write here in solution y is equal to, let y is equal to cos of x square plus a square. So for that we know the derivative of cos x. So we write here derivative of y as dy by dx. Derivative of cos x is minus sin x, and for composite function y is equal to cos of f of x. We have to find the derivative of outer function. So we write here dy by dx equals to outer function is cos. So we write here minus sin this f of x as it is. Then we find the derivative of this f of x, that is f dash of x. So we use this concept here. So we write here differentiate with respect to x. Now outer we write derivative of y as dy by dx. Outer function is cos. So derivative of cos is minus sin. Keep the bracket value as it is, x square plus a square, that is the value of f of x. Then we have to find f dash of x, that is derivative of this x square plus a square. So we write here d by dx of x square plus a square. Then minus sin of x square plus a square. Then derivative of x square is twice x. Derivative of a square is 0 because a is constant. Because we are differentiating with respect to x, here value is a, letter is a. So when we differentiate this a square, we get its derivative as 0. So we write this 2x plus 0 as 2x. So we write 2x at first position, this minus sign. So minus 2x into sine of x square plus a square. Now see second sub question. In root e raised to the power 3x plus 2 plus 5. So here value in root. So we write here y is equal to root x. We know the derivative of root x. So we write derivative of y as a dy by dx. Derivative of this root x as 1 upon 2 root x. So here in place of x, value is e raised to the power 3x plus 2 plus 5. So this is composite function. So we write this as let y is equal to e raised to the power 3x plus 2 plus 5. So we differentiate this outer function. Here outer function is root. So we write that in the form 1 upon 2 root. So we write here differentiate with respect to x. Now derivative of y, we write with respect to x as dy by dx. Then derivative of root as 1 upon 2 root. So we write e raised to the power 3x plus 2 plus 5 in root. Then we have to write derivative of value in root. So here value is e raised to the power 3x plus 2 plus 5. So we write here 1 upon 2 root e raised to the power 3x plus 2 plus 5 into. Now here we have to use addition rule. So first we have to find the derivative of first term, then derivative of second term. So we write here d by dx of e raised to the power 3x plus 2 plus d by dx of 5. Now this 5 is single constant, so its derivative is 0. 1 upon 2 root e raised to the power 3x plus 2 plus 5. Now here e raised to the power 3x plus 2, this is in composite form. So for that we know that d by dx of e raised to the power x is e raised to the power x, and this is composite function. So we have to apply first standard form, then we have to find the derivative of this 3x plus 2. So we write here e raised to the power 3x plus 2, because derivative of e raised to the power x is e raised to the power x. So we write derivative of e raised to the power 3x plus 2 as e raised to the power 3x plus 2. Then we have to find the derivative of this 3x plus 2. So we write in multiplication d by dx of 3x plus 2, and this derivative of 5 single constant is 0. Now we write here 1 upon 2 times e raised to the power 3x plus 2 plus 5 into, or you can write here bracket, in bracket e raised to the power 3x plus 2. Here derivative of 3x is 3, derivative of 2 is 0. So we write here 3x, derivative of 3x is 3, derivative of 2 is 0. So we write here e raised to the power 3x plus 2 into 3 plus 0. So we write into 3 upon 2 times e raised to the power 3x plus 2 plus 5. So you can write this 3 upon 2 at first position. So we write here 3 by 2 e raised to the power 3x plus 2 upon in root e raised to the power 3x plus 2 plus 5. So in this way you can find the derivative of this root. Now say third sub question, we have to find the derivative of log of tan x by 2. So here log is outer function and tan x by 2 is inner function. So first we see this log, this tan and this x by 2. Here we have to find these three derivatives. So we know the derivative of log x, d by dx of log x, that is equal to 1 by x. Then we know the derivative of tan x, that is derivative of tan x is sec square x. Then we know the derivative of x. So here derivative of x is 1. So we have to use these three formulas here. So first we write the given part as y. So we write here in solution, let y is equal to log of tan of x by 2. So we write here differentiate with respect to x. Now derivative of y with respect to x, we write dy by dx. Derivative of log is 1 upon, so we write here 1 upon tan x by 2. Then we have to find the derivative of inner function, that is d by dx of tan x by 2. Now this inner function is also composite function because we require tan x, but here in place of x value is x by 2. So we write here 1 upon tan x by 2 as it is. Then derivative of tan x is sec square x. So we write this as sec square x by 2 into d by dx of x by 2. So we write here x by 2 as 1 by 2 into x, which is convenient for differentiating. So we write here 1 upon tan of x by 2 into sec square x by 2 into this 1 by 2 is constant, which is with variable x. So we write here 1 by 2 in multiplication, then d by dx of x. So we write here sec square x by 2 upon tan x by 2 into, so we write this 1 by 2 in multiplication first. So 1 by 2 in bracket sec square x by 2 tan x by 2 into derivative of x is 1. Now you can simplify this. So we write this as 1 by 2. This sec square x by 2 we write 1 upon cos square x by 2. Since sec x is equal to 1 by cos x. So we use this concept. Then this tan x by 2. So 1 upon tan x, we write cot x. So this cot x is cos x upon sin x. So we write 1 upon tan x as cos x upon sin x. So here in place of x, value is x by 2. So we write this tan x by 2 as cos x by 2. Cos x by 2 upon sin x by 2. So this cos x by 2 get cancelled with this 1 cos x by 2. So in denominator we get 2 times sin x by 2 into cos x by 2, which is half angle formula. Sin 2 theta is equal to 2 sin theta into cos theta. So from this we write here sin theta is equal to, or you can write sin x is equal to, if we divide each term by 2, so these two get cancelled, we get sin theta equals to here 2 sin theta by 2 into cos theta by 2. So we use this concept. In place of theta we have value x, so we write this as sin x. So we write 1 upon sin x and 1 upon sin x, that is cosec x. So here we write the derivative of log of tan x by 2 as cosec x. Now see sub question 4. So this type of problem we solve in main question 1. So we write this as let y is equal to square root of tan of root x. That means here three functions are given. This outer function is root, this inner function is tan, then again inner function is root x. That means we have to find three derivatives here. So first is y is equal to root, that means its derivative we get 1 upon 2 root. Then we have to find the derivative of tan. So we know the derivative of tan. If y is equal to tan, then derivative of tan x, that is sec square x. So we write dy by dx is equal to sec square x. That means here we have to use these two rules. Dy by dx is equal to 1 upon 2 root x for root x. Then dy by dx equal to sec square x for y equals to tan x. So we differentiate here, differentiate with respect to x. So we write a derivative of y as dy by dx, outer function is this root. So we write 1 upon 2 root if the value in root as it is tan of root x. Then d by dx of this inner function, that is tan root x, tan of root x. Therefore 1 upon 2 root tan of root x into derivative of tan is sec square. So we write sec square root x into d by dx of root x. Because in place of x value is root x here. So this tan root x is composite function. So outer function is tan, inner function is root x. So first we find the derivative of tan, then we find the derivative of root x. So we write this as sec square in numerator. So we write sec square root x upon 2 times tan of root x into derivative of this root x is 1 upon 2 root x. So we write this 2 into 2 4. So we write in answer 1 by 4 sec square root x upon tan of root x. So this will be this is the final derivative. If you can simplify, so you try to solve this yourself. Now see sub question 5. Cot cube of log of x cube. So this cot cube we write as cot of log of x cube bracket raised to the power 3. Because we know that cot cube x can be written as cot x bracket cube. So we use the same concept here. So here outer function is power function. So here we have to use here concept of x raised to the power n first. That means we have to find derivative of x raised to the power n. Then we have to find derivative of cot. Then we have to find derivative of log. And then at last we have to find derivative of x cube. That means we have to use 4 rules here. First is power, then cot, then log, then algebraic. So here we write this as let y is equals to cot of log of x cube. You can use square bracket also, bracket raised to the power 3. So we differentiate with respect to x. So we write a derivative of y as a dy by dx. First we write the derivative of power. So we write power in multiplication. So 3 in bracket cot of log of x cube. Then we reduce the power by 1. So we get here 2 into. Then we have to find d by dx of, that is derivative of outer function, cot of log of x cube. That means here first outer function is this raised to the power, that means power function. Then when we find the derivative of power function, then we have to find derivative of this cot. Then this cot becomes outer function. So we have to find derivative of cot here. So 3 in bracket cot of. So we write this as cot square again. So cot square log of x cube into derivative of cot x is. So we know that derivative of tan x is sec square x. Derivative of cot x is minus cosec square x. We use the concept d by dx of cot x, that is minus cosec square x. So in place of x, value is log of x cube. That means this is again composite function. So we write a derivative of cot x as minus cosec square log of x cube. Then we have to find the derivative of log. So into d by dx of log of x cube. Then we write this as minus 3 cot square log of x cube. We write this minus sign with 3. Then cosec square log of x cube into, so derivative of log is 1 upon, so we write 1 upon x cube into d by dx of x cube. Now see here, first we find the derivative of power, then we find the derivative of cot, then we find the derivative of this log. Now we find the derivative of x cube. So we write here this minus 3 into cot square log of x cube into cosec square log of x cube into 1 by x cube into derivative of x cube is 3x square. So in next step we cancel this x square with this square in x cube. So remaining is x. So 3 into 3 9. We write here minus 9 by x cot square log of x cube into cosec square log of x cube. See next sub question. 5 raised to the power sin cube x plus 3. So we have to use here d by dx of a raised to the power f of x. So here in place of a value is 5, in place of f of x this sin cube x plus 3 function is here. So we know that derivative of a raised to the power f of x is a raised to the power f of x into log a into f dash of x. if you know the standard form, d by dx of a raised to the power x is a raised to the power x into log a. So here in place of x, value is sin cube x plus 3, that means this is composite function. So we write this as, in solution, let y is equal to 5 raised to the power sin cube x plus 3. So we write here differentiate with respect to x. So derivative of y with respect to x, we write dy by dx. Here we have to apply a raised to the power f of x form. So we write here derivative of 5 raised to the power sin cube x plus 3 as 5 raised to the power sin 3x plus 3 into log 5 into d by dx of this sin cube x plus 3, sin cube x plus 3. So we write here this log 5 at first position. So log 5 into 5 raised to the power sin cube x plus 3 into, so we have to find derivative of sin cube x first, then we have to find derivative of 3. So we write here d by dx of this sin cube x, we write sin x bracket raised to the power 3 plus d by dx of 3. Then log 5 as it is, 5 raised to the power sin cube x plus 3 as it is. Then derivative of sin cube x. So we have to apply here power rule first. So we write here power in multiplication. So 3 in bracket sin x, its brackets here into derivative of sin x, d by dx of sin x, and derivative of this 3 is 0. So we write here final answer as log 5 raised to the power sin cube x plus 3 in bracket. So we write here 3 into sin square x, 3 into sin square x, and derivative of sin x is cos x, so into cos x plus 0. So we write this as 3 log 5 into sin square x into cos x into 5 raised to the power sin cube x plus 3. Now see next sub question 7. We have to find derivative of cosec of root of cos x. So first we count the total number of functions here. So outer function is cosec, then inner function is root, then innermost function is cos x. That means 3 functions are here. So we write here in solution, let y is equal to cosec of root of cos x. So first we find the derivative of cosec, then we find the derivative of this root, then we find the derivative of cos x. So we write here differentiate with respect to x. So we write derivative of y as dy by dx, derivative of cosec. So derivative of cosec is minus cosec of root of cos x into cot of root of cos x. Because we know that d by dx of cosec x is minus cosec x into cot x. So in place of x, value is root. So we write here derivative of this cosec of root cos x as minus cosec of root cos x into cot of root of cos x into d by dx of, so inner function is this root, so we write root of cos x. Then we write these first two terms as it is, minus cosec of root of cos x into cot of root cos x into, so we have to find a derivative of root first. So we write 1 upon 2 root cos x, then derivative of cos x. So we write here minus cosec of root of cos x into cot of root of cos x into 1 upon 2 root cos x, and derivative of cos x is minus sin x, so we write in bracket as minus sin x. So we rearrange all these terms. So we write here minus minus plus. So we write sin at first position. So sin x into here cosec of root of cos x, then into cot of root of cos x, and this 1 upon 2 root cos x we write in denominator, so 2 root of cos x. So in this way we find the derivative of cosec of root of cos x. You first always count the number of total functions, then check the derivative you calculate or not. So first you have to find the derivative of cosec, that we get minus cosec into cot. Then we have to find derivative of root. So derivative of root is 1 upon 2 root. So we get 1 upon 2 root. Here in place of x value is cos x. So we write 1 upon 2 root cos x. Then we have to find derivative of cos x. Cos x derivative is minus sin x. That means we find here 3 derivatives, and that 3 derivatives we write in multiplication. Now see next sub question, question 8. Here function is log of cos of x cube minus 5. So total number of functions are 3. Log function, cosine function, cos function, then algebraic function. So we have to find 3 derivatives here. So we write y is equals to, write in solution, that y is equal to log of cos of x cube minus 5. So we write here differentiate with respect to x. So first we find the derivative of log. In left hand side we find the derivative of y. So we write dy by dx is equal to derivative of log is 1 upon. So we write here 1 upon cos of x cube minus 5. Then we have to find the derivative of this cos. So derivative of cos of x cube minus 5. So we write here 1 upon cos of x cube minus 5 into derivative of cos x is minus sin x. So we write here in bracket minus sin of x cube minus 5 into d by dx of. So here we have to find the derivative of this x cube minus 5. So we write here into d by dx of x cube minus 5, which is equal to, so we write this term as it is, 1 upon cos of x cube minus 5 into minus sin of x cube minus 5 into, so derivative of x cube is 3x square. So we write in multiplication 3x square. Derivative of 5 is 0. So we write this 3x square minus 0 as 3x square. So we write 3x square at first position, and here sign is minus. So we write minus 3x square sin of x cube minus 5 upon cos of x cube minus 5. So we write this sin upon cos as a tan. So we write here minus 3x square tan of x cube minus 5, which is derivative of this log of cos of x cube minus 5.